Hello and welcome to this video series which is about introduction to Hadoop. So this video is going to be a pretty short one, not too lengthy, and this is basically aimed almost like towards all kinds of audiences whose work is somewhat related to information technology. They might not be computer science geeks, they might not be programmers, but people who are working in the field of information technology, all kinds of people who have some basic understanding about what a computer is, what is the difference between hardware and software, and if you're able to identify the differences between, hardware, software, and what is a mobile operating system or what is a desktop operating system, if you're able to identify these things, you can pretty much be able to understand what is Hadoop at a very high level. I'm not going to get into the details and nuts and bolts of what exactly Hadoop does and what kind of problem it can be used for. I'm not going to get into all those details, but just trying to make it very simple and trying to actually, break the ice, get your first understanding of Hadoop in a very simple way, as simple as possible. So let's get started with this introduction. Forget about all the computer science problems. Suppose you have a room which has four walls and a ceiling, and you hire a painter to actually finish the paint job. This guy is an expert at painting, but he approximately takes 2 to 2.5 hours to finish the paint job for one wall. Like in this room, which has four walls and a ceiling, it would almost take 10 to 12 hours for this guy who's an expert painter to finish the paint job. Now, a simple question is, you are a bit impatient. You want to move into this room, probably say in less than 4 hours. So, how would you finish this job? This guy, this painter out here, with this one man out there, he would take almost 10 to 12 hours to finish the paint job, which is almost like a full day of work. If you want to get the job completed in almost say less than 4 hours and move into the room, the basic thing what actually comes to human mind is I don't mind spending money, I can just hire more painters. So you would actually rope in some more painters, say probably you would have four painters working together parallelly, each guy working on each of the walls, or probably you can also have five painters, one guy for each wall in the room, and the fifth guy actually is taking care of painting the ceiling. So probably if you hire more resources for this kind of a job in real world, there's a very high chance that you can finish the paint job of this room in less than 3 hours, or you can actually move into the room after 4 hours. So the basic common sense is if you can actually hire more resources, or if you can actually have more resources working for you, then probably you can get the job done. In this case, it's definitely you can get the job done very, very quickly. Now, fortunately, in the field of computer science, there are literally a lot of problems, a different kind of problems, which can take advantage of the processing power of multiple computers. Unfortunately, in the same field of computer science, there are also a lot of problems which cannot take advantage of the processing power of multiple computers. So in simple, we are just going to talk about those problems in the field of computer science which can be solved much faster if you can try solving the same problem using multiple computers. Let's see actually a simple example like that. Imagine I'm having an input file of size 1 GB. It's filled with numbers. Numbers they're separated by space. It's just integers. Now I have this guy over here, the computer on the right hand side. This guy, this computer, basically, he has a software installed on it. That particular software is able to process the input file, which is 1 GB in size, add up all the numbers and give you the result. Now say the sum of all the numbers in this input file is going to be 10,000. Approximately, let's assume for the sake of discussion that it's taken 50 seconds to finish this job. Now, the same job, the same operation of adding up all the numbers in an input file can be done much faster if this input file actually is split into two, not exactly two equal halves, but approximately equal halves. I'm giving this to two different computers of the same configuration as last time. Both of them have the same hardware specifications and both of them have the same software installed to actually compute the sum of the numbers in the input file. The computer in the left hand side actually is going to add up all the numbers and give the output as like 6,000, and the computer on the right hand side is going to add up all the numbers in his input file and throw the output as 4,000. And you have another happy guy in the yellow computer sitting down here who's waiting for the results of computation of these two computers on top. And once both the computers actually give out the result, it's going to just add up the result and show you the answer like, hey, I'm done. The sum total is going to be 10,000. And for the sake of discussion, let's assume that the time taken is 30 seconds. So the previous problem, it took 50 seconds to finish it using just one computer. And in this problem, it's taken 30 seconds. Definitely, it's like improvement by at least 45%. Some of you out there might be thinking like, okay, I used one computer in the previous slide. It's taken me 50 seconds to compute the answer. But right now, I've actually taken two computers. Literally, the third one is just waiting there for the other two computers to add up and give the result. But it should have taken ideally, like 25 seconds. Where is the 5 seconds extra being used? It's actually the time taken for coordination. The yellow guy in the bottom needs some extra time to coordinate the results from the above two computers, which is actually doing the processing, and then add it up and give it to you. So this 5 seconds is going to be an extra overhead, or it's also called as, the coordination time between all the computers. So this is a simple example of, trying to explain how the computation speed can be improved by splitting the input file and giving it to multiple computers. And this is a very basic example of how parallel processing happens. So this parallel processing or grid computing or cluster computing or supercomputing, all these things have been in place since almost like 2 decades. This is nothing new to the world of computer science. So if you go back like a few years ago, like a few decades ago, like a couple of decades, supercomputers were exactly like hundreds and literally thousands of computers interconnected to solve some complex data analysis problems. However, there were very few manufacturers of supercomputers, like the most famous ones being the IBMs and the HPs, and the people who used to buy, or the organizations who used to buy these supercomputers were like NASA, the US Department of Defense, or like the weather forecasting companies, and those companies which basically involve trading of stocks, the rich banks in the Wall Street. So these were the cash-rich companies, huge organizations which had a lot of cash with them to go and they were able to afford a supercomputer. But one drawback of supercomputers is like they didn't have a general purpose operating system which can be installed on the supercomputer and it can be used very easily. No, that wasn't the problem. It's not as easy as you buy a laptop or a desktop, say from Amazon or from eBay, and it comes pre-installed with the Apple operating system, or it comes pre-installed with the Windows operating system. So that was not the case here. If NASA, say for example, has purchased a supercomputer from IBM, and there would be various kinds of departments within NASA. Like one department would require the supercomputer to process the information sent by, say, Mars Land Rover. It's going to process the huge amounts of data which is going to be sent by, say, the Mars Land Rover or the satellites. So they would have to write the custom software to handle this problem. Say another department within NASA, they want the supercomputer to perform some kind of, analysis of solar flares, the data collected from satellites for analyzing the solar flares. Now, the problem is that department will have to write their own custom software to manage this and perform this job, or to complete this job. So this was the biggest problem, and they need to have a set of dedicated network administrators to reconfigure things as needed, and they need, every team actually needed a dedicated software engineers, a team of software engineers who would write the proprietary software, maintain it, and also enhance the software for each individual subdivisions or sub-organizations within a major organization. So there wasn't a general purpose framework, or there wasn't a general purpose operating system like environment on these supercomputers, which made it extremely difficult for many mid-sized organizations to buy supercomputers from the major manufacturers. And it's actually a pretty expensive affair. Now, what exactly Hadoop is basically is, it solves this problem of having to write custom software or a software framework to handle the tasks in a supercomputer. So Hadoop is like an operating system like environment on a supercomputer like environment, or for a parallel processing grid. So Hadoop is pretty much like, in a simple way, is like what Android has done. So you pretty much know, like, there are like a ton of hardware manufacturers who basically keep releasing phones every 3 months and every 6 months. And some of the famous manufacturers, the hardware vendors of phones, include like the Samsung, the Sony, and the HTC, etc. But you don't really have to worry about like what kind of memory goes inside the phones, what kind of processor goes inside the phone, how is the processor and the memory going to interact. You don't worry about all those things. All you have to worry is like what flavor of, or what version of Android actually is installed on all these phones. Simple. So the Android is that software, which is basically the operating system which hides all the abstractions present in the hardware, and completely gives you peace of mind of not having to worry about the hardware details and how everything is interconnected inside, and just gives you a seamless interface to just work on whatever apps you need just from the Play Store. So you just have to go to the Play Store, download the apps depending upon your needs, install them on your Android phone, and start working with them. So all you have to know is like how to install an app. That app is going to solve a problem for you. So you have different kinds of apps, almost like a ton of apps for different kinds of purposes. So what Hadoop has actually done is like, it's almost done something similar to what Android has done to the world of smartphones. But smartphone is just like a single device. But when you're talking about Hadoop, Hadoop is like a software framework which is being installed, or which would be sitting on multiple computers in a cluster. Say you interconnect 100 computers for solving a distributed computing problem in your organization. And now what Hadoop does is like, it's sitting on top of all this 100 computers and trying to manage everything what is happening in these 100 computers like a distributed operating system would do. And the biggest advantage of Hadoop is that it's going to be scalable, and it's free of cost. And scalable in the sense that if you want to add 100 more computers, you can pretty much do it pretty easily. It's not going to be a Herculean task to add 100 more computers to an existing cluster of 100 computers. So it's free, it's scalable, and it's like very easy to maintain when compared to the previous state of supercomputers. And now almost like any small or a mid-sized organization can afford to have a cluster, a computer cluster, for their data intensive processing needs. So Hadoop has unleashed the power of, like supercomputing like environment for almost like every kind of user. You don't have to be super cache rich like the big organization which once could only afford the supercomputers. Now like you can have a parallel processing grid pretty much in your office. So this is what Hadoop has actually done to the world of parallel computing. A general purpose operating system like framework managing all the computers, and it makes your job easy to actually get your work done. But why is Hadoop a buzzword right now? Like, why wasn't Hadoop a buzzword earlier? Even if Hadoop would have been introduced, say, 15 years ago, or say Hadoop would have been introduced, even if there would have existed a general purpose operating system like framework, like say 20 years ago, not many people would have been really interested in this, because the necessity of having a cluster of computers to solve some data intensive problems, there wouldn't have been much need for many organizations back then. Right now it is a buzzword for the main reason is like we have a ton of data, a variety of data, and this variety of data is, and this large variety of data is getting generated at a tremendous pace. Like you can just read through some of the points over here. Like Facebook generates around like 500 terabytes of data each day, and Facebook handles approximately 300 petabytes of data on a day-to-day basis, and 300 hours of video are uploaded to YouTube every minute. So almost like this is just a glimpse. This is just a glimpse. It's just like the tip of the iceberg in terms of like data generation and analysis. There are like a lot of organizations which is sitting on a heap of data, and they want to process the data. The data is so huge, and the variety in the data is so diverse, and the rate at which the data is getting generated is humongous. So organizations which basically want to deal with this data, analyze the data, process the data, they want a supercomputer like environment. Not exactly the similar kind of supercomputer what NASA has, but something like much more smaller in size. And NASA would have 1,000 computers in the cluster, but whereas a mid-sized organization might just need to have like 300 to 400 computers in the cluster. So that's the reason why Hadoop actually is pretty much in demand right now. Like many people are talking about Hadoop because they need to know how to configure, install, and get things running so that they can start to process the data in a distributed environment by making use of the raw processing power of every computer in the cluster. So this is what Hadoop has actually done, and that's the reason why Hadoop has basically done things easier for parallel processing by giving you a general layer of abstraction in an operating system like environment. And that's the reason why people are crazily running after learning Hadoop. That's the reason why Hadoop skills are most in demand right now. So that's the end of it. So